Hello everyone. So previously we had discussed on the topic designing a logger system and we had successfully designed as well. Yep. Then today what we'll do, today what we'll be doing, let's design a URL shortener that URL shortener actually that's similar to the bit.ly website. Yeah. So you can just check the bit.ly if you don't know. I'll just go with a completely self-contained single file. Yeah. So this is purely for the this one what do we call demo purpose. Yeah, this is purely for the demo purpose. Let's design this one. What do we call it is going to be completely self-contained single file just for the demo purpose, right? So we'll not be making use of any external db, will not be making use of anything. It's going to be the single file as I've said. So this one is just for the understanding purpose again. Yeah. uh, as I've said. Yep. So what's the question here? Design a URL shortener system like bit.ly that can convert long URLs into the short aliases, into unique short aliases, and retrieve the original URLs efficiently. And they have asked us to retrieve the original URLs efficiently, right? So implement a self-contained solution without any external database suitable for the demo purposes. Yep. So this is fine, I believe. Yep. Now let's do one thing. Let's collect the this one functional as well as the non-functional requirements. Then let's move on with the concurrency as well as the data model. Then we can just write the code and discuss the limitations as well as the alternative algorithms. Yeah. So let's do this. Initially, let's move on with the this one. What do we call functional as well as the non-functional requirements? Yeah. Now let's move on with the functional and the non-functional requirements here. So see, the functional requirements shorten a long URL to the short alias. So this is fine. Again, this is just the self-contained single file we'll be going with. Yeah. So this is going to be the most compact one. Yeah. Right. So this is fine. Uh, we have to redirect the short URL to the original long URL. Right. So handle collisions in the short URL generation. This one also we have to keep in mind. The final one here is track the number of hits. We have to track the number of hits as well. Next, let's move on with the non-functional requirements here. So non-functional requirements, the first point here is short URLs should be unique and minimum length. Short URLs should be unique and minimum length. This is fine. System should be fast for the lookup. System should be fast for the lookup and insertion. System should be fast for the lookup and this one insertion. Yep. Should be memory efficient. This one efficient for the small scale demo. Should be memory efficient for the small scale demo. The final one would be it should be easy to extend to persistent DB or the persistent database later if needed. Persistent database later if it is needed. Yep. So this is about the non-functional requirements. Now as we have the functional as well as the non-functional requirements, so let's do one thing. Let's move on with the concurrency as well as the data modeling. Yeah. So before concurrency and the data modeling, let's discuss the algorithm choice as well. Yep. So yeah, here we'll be making use of the base 62, this one encoding of a unique ID to generate the short URLs. Yep. So this is just what happens. So basically we'll be just going with a single letter just for the demo purpose here. So if something some URL, if I give some URL, it'll give us just the single character in this case. We are not shortening this one entirely. This is just for the demo purpose, as I've said. So this is going to be just for the understanding purpose. Yeah. So we'll be making use of the this one base 62 encoding of a unique ID to generate the short URLs. Yep. So we'll maintain a dictionary, nothing but the hash map for the fast mapping of short, this one short to the long URLs and vice versa, long to short. Yeah. So this ensures BICO of one insertion and retrieval for the demo scale. This ensures BICO of one insertion and retrieval for the demo scale. Yep. So now let's move on with the main part, nothing but the concurrency and the data model discussion. Yeah. So now here, see, first thing, the data model, we will be going with the URL DB. Nothing but here, when I say URL DB, so I am speaking of the short URL to long URL conversion of the this one. You can just consider in this way, short URL. Sorry, 1 second. What happened to this one, man? This one, short URL to long URL. Yep. So this is fine, I believe. This one reverse DB. This is again long URL to short URL as discussed earlier, right? So this one will be long URL to short URL. Yep. So this is fine, I believe. Yeah. So the final one, we have set the counter equals 1. This is nothing but the auto increment unique ID. Auto increment unique ID. Yep. Let's move on with the concurrency part. We are done with the data modeling part, right? So let's move on with the concurrency part here. So concurrency, so for a single threaded Python demo, so as we are going with a single threaded Python demo, right? So no complex, this one, locks are needed. Yeah, no complex locks are needed here. So this is not required actually. This is fine. No complex locks are needed. The next one is for the production. So we have to go with the atomic increments as well as the thread safe dictionaries will be needed actually. Yeah. So this one we have to keep in mind, man. Now let's move on with the UML diagram. Yeah. So just look at this. We will be having the URL shortener class, this one main. So then we'll be going with a URL DB. One second. So we are going with a this one reverse DB of this one dictionary. This one dictionary. This is fine. So we are going with a counter of int. So these are this one counter which is of the type int, and this one shorten and retrieve are the helper methods actually that we'll be making use of. Yeah, shorten and retrieve again. They are the helper methods that we'll be making use of. Right. So this is the UML diagram. Yep. So exact same thing that will be this one articulating in the form of code along with the logic. That's it. Yeah. So now let's start writing the code as we had discussed the UML diagram already. Yep. So first let's do one thing. Let me go with import string here. Import string. So this is fine. Let me go with class uh, URL shortener here. This is also fine. So within the URL shortener class, so I'll just go with a def init. So this is fine. Mm, yep. So within the initialization part, so let's go with a short URL as well as the long URL, right? So I'll just go with self dot URL underscore DB. So this one, this is fine. And yep, self dot this one reverse. Let me go with here. A reverse DB is the term that we use, right? So reverse DB. Let me set this one to the this one. These two actually what we are doing, we are going with a short URL to the long URL, and the second one reverse DB, nothing but the long URL to short URL. We have discussed this one already. Also, we will be going with a counter as well, right? So in the data modeling, we have seen this one self counter. Let me set this one to the one, and also self dot alphabet. So let me go with a, so I'll just go with string dot, let me go with ASCII here. So this is fine. ASCII letters. Yep, ASCII letters plus I'll just go with a string dot digits, combination of letters and the digits. So this is fine, man. Now let's do one thing. Let's convert the integer ID to the base 62 string, right? So let's make use of the helper method encode here. So I'll just go with def encode. I'll just go with self comma num, self comma num. Yep. So this is fine. If num number is equivalent to the 0 actually, then what we will do, I'll just return here this one self dot let me go with the alphabet here, alphabet of 0. Yep. So this is fine. So the next part, let me initialize s to empty array. So next let's go with a base. Let me set this one to the length of self dot alphabet. So this is fine. Yeah. Now let's write the simple while condition here. While num greater than 0, while number is greater than 0, then let me append, let me append. I'll just go with self dot alphabet. So this is fine. Alphabet of number modulo. So let me go with base here. So this is fine. Next, number equals number by base, right? So I'll just go with number equals number by base. So this is also fine. The final one, we have to return this one, right? A reverse string actually. So I'll just go with here a return. just make use of the join here. Yep, let me pass the reverse of. Why this is showing like this actually? This is fine. Oh, this one second. Yep, this is fine. Now let me go with the reversed of let me pass the string s here. So this is fine, I believe. Yep. So we are done with the encode helper method. Now, as we had discussed in the UML diagram, if you remember, we will be going with the shorten as well as the retrieve helper methods. Shorten is used to shorten a given long URL, and retrieve is used to retrieve the original URL, right? So I'll just go with the def here. Let me make use of the shorten. So this is fine. Along with the self, let me go with a long URL. Along with the this one self, let me go with a long URL, right? So if long URL in self, this one dot, let me make use of the reverse DB. This is fine. Yep. The next if condition, sorry, let's return here something. Just go with the self dot reversed. So this is showing actually. Let's go with the reverse DB itself. Yeah. We have to pass the long URL. Sorry. Mm, Yep. So this is fine, man. So the next step would be, let me go with a short URL here. Basically, what we'll be doing in the shorten, we'll shorten a given long URL, right? So short URL, let me assign this one to the self dot encode. Mm, we need to encode here. Let me pass the counter actually. We have considered counter. Yep, self dot counter. So this is fine. Next dot URL DB actually. This is fine. Of let me pass the short URL. So this is fine. Short URL equals long URL. This is also fine, I believe. Next, self dot. So I'll just go with the reverse DB here. Yep, this one reverse DB of long URL So let me assign this one to the short URL. This one. Yep. So this is also fine. Now let's go with a counter here. So let's assign the counter to counter plus 1. Yep, so this is also fine. The final one is return. What we need to return here? Short URL, right? We need to return short URL. Yep, the next one is we have to retrieve the original URL. So I'll just go with the def retrieve. I'll just go with def retrieve. Let me go with a self here, short URL. This is fine. Yep, so within this helper method retrieve, so let me return. So we have to retrieve the original URL, right? So I'll just go with here URL DB. Yep, URL DB. So let me make use of the get operation here, right? Get of, let me pass the short URL. Along with the short URL, let me pass none, other parameter, none. Yep, so this is fine, man. Now we are done with the this one. What do we call? Coding actually. We are done with the coding part basically. Yep. So this is it for the code. As I've said, this is self-contained single file without any external DB or other stuff. Yeah, this is just for the demo purpose, right? So let's go with the example usage. Let me do one thing. This is it for the code. Let me get the example from the Google man. Just give me a second here. So let me paste it over here. So this is fine. Yeah. We are just going with the shortener, this one variable name. We are calling the URL shortener here, right? So the class, basically the main class URL shortener. URL1, I have set this one my URL, and URL2, I have set this one, right? So shortener, we are making use of the shorten here. Helper method we have already written. Shorten URL1 and URL2. We are just going with the base 62 this one encoding, right? So we'll get the this one, what do we call? Uh, alphabet actually, just one alphabet. This will be converted to the single alphabet, right? So this is fine. Retrieve YouTube URL shortener dot retrieve string one we are retrieving. So this one, this URL as well as the this one, second URL1 and URL2, right? So we are just making use of the retrieve here along with the this one. These are the four what do we call print statements. First, we are just going with the YouTube, this one YouTube and the GitHub link that I have provided, just printing the original ones. Then we are just retrieving the right shortened URLs, right? So this is fine. Now before mm, let's do one thing. Yeah, actually, the shortened URL for the YouTube we have to get, shortened URL for the this one GitHub string to we have to get. Then um, we are just going with the main retrieve YouTube URL. So main original one. So this one, sorry, I said it reverse, right? So this one we have to get this link itself. For this one shorten this one print statement, we have to get this link actually. For the this one, we have to get the short URL for these two links actually. S1 this link. So we'll get basically a single character. For this one also, we'll be getting the single character that is shortened, right? So we are making use of the base 62 encoding as we're just going with the base 62 encoding just for the demo purpose, right? So this is fine. So let's do one thing. Now let me give Control J here as we have completely complete understanding on the this one, what do we call code. So let me run the code. I'll just go with copy, sorry, Python followed by the file name.py. Yep. So yeah, see here, shortened URL for the YouTube B we are getting, shortened URL for the GitHub we are getting C. Again, we're just going with a base 62 C. This is how we have this one, what we call shortened the URL. Right. So we are just going with a base 62 just for the demo purpose, right? So this is the main URL actually, and these two are the main URLs. Yep. So I hope this part is completely clear, man. Yep. Yep. Now, as we have written the code and as we have discussed the output as well, now let's discuss the limitations of the code that we have written along with a future this one, future scope, right? Or the this one you can just call alternative algorithms and the trade-offs, right? So these two things we are left with discussing these two things. Let's discuss those two. First, let's discuss the limitations of the code. So now the first part here would be not persistent, right? It resets every run. Not it is not persistent, it resets every run. So no handling for very high concurrency, right? So no handling for very high concurrency. This is one of the limitation, right? No analytics as well. No analytics as well. So this is one of the limitations. And the final one is counter-based approach may leak URL creation order. As I've said, this is just for the demo purpose, right? Counter-based approach may leak URL creation order. This is one of the limitations. So these are some of the limitations I wanted to discuss with you guys. Yep. Now let's move on with the final one here. Alternative algorithms and the trade-offs, right? So when I say alternative algorithms and the trade-off, so we can just go with a hashing long URL. Hashing long URL, that also we can do, right? Hashing this one, basically hashing a long URL in the sense we can just make use of MD5 or SHA, right? So we can just go with a this one shorter collision risk. Basically, if we make use of the MD5 or the SHA, so there will be shorter collision risk and but may have the collisions as well. Need resolutions in this case. Yep. So for this one, hashing long URL. So the second one is a random string generation, right? Random string generation in the sense we have to avoid the sequential order. So we can just go with a random string generation as well, but we have to avoid the sequential order. Potential collisions need this one regeneration. So this one also we have to keep in mind. The third one, we can just go with a database backed system as well, right? For real scale, we can store the mappings in the database, right? And we can just handle the millions of URLs efficiently, quite efficiently. Yeah. So this is it for the this one. What do we call? You're designing a URL this one shortener similar to the BitLY, right? So yep, I hope whatever we discussed is completely clear, man. Yeah, we went step by step. One is functional and non-functional requirement. Then we went with a this one. What do we call? Mm, 1 second. This one concurrency and the data model discussion. Then we went with what do we call UML diagram, right? Also we discussed the algorithm choice as well. Whatever the algorithm, this one we chose actually that one as well. Finally, after the UML diagram part, we wrote this one code actually. We discussed the output along with the code, and then we discussed the this one limitations, and finally we discussed this what do we call alternative algorithms as well as the this one alternative algorithms and the trade-offs, nothing but the summary. Yep. So this is fine. So this is it for the what do we call designing a URL shortener like BITLY, right? So yep. Mm, yep. So this is it actually. Yep. So we have successfully designed this one URL shortener similar to BITLY. So for now, this is it. Thanks for watching, guys.